Hello everyone, my name is Kim Christensen and today I want to show you our new simulation tool or calculation tool for CO2 heat pumps. We are able to calculate both air source and water source, and I will show you a little bit around. Of course, calculation tools are extremely important because this is the way we are simulating how well our heat pumps will be performing in a real life environment. So have a look here. The tool is, I'll just move this a little bit. The tool is separated into different tabs. First, I can configure my system, and I have a view of what system I'm using for simulation here. I can have IT compressors and no IT compressors, and of course, the drawing to the right is changing depending on what I want to calculate on. I can also choose if I want to use ejectors or no ejectors in my CO2 heat pump. This is what I'm doing here. A pure high pressure valve solution, high lift ejectors or low lift ejectors, depending. So the first thing I'm doing is I have to select compressors, and this is what I'm doing here. We have different brands. And we have different models on compressors. I also have to select suction gas heat exchangers and the thermal efficiency of suction gas heat exchangers. I do that here. I can close this tab. Then, of course, I have to select the gas coolers. That is the heat exchangers where we are rejecting all the heat from the heat pump into the water side. And of course, we have different models here. And of course, evaporator side, depending if it's an air source or water source. In this case, I'm calculating an air source heat pump. And of course, we have different types of air source evaporators that we can use. I can select them from this drop down. And then, of course, I have to tell the software the sound level and temperature of the air here. Then, of course, we can use subcoolers if we want to do that. This is typically when we have high return. In this case, I just choose not to have a subcooler. And then, of course, the expansion device, as I showed before, and then various input regarding pressure drop and safety margins and so on. By doing this, I can actually calculate the heat pump. In this case, I am heating water from 37 degrees up to 75, and you see this is the simulation of the gas cooler, and of course the evaporator down here. I'm also doing the simulation, and the results I actually have to the right. So this is an H2600. I'm able to deliver, in this case at 5 degrees ambient, 3.1 megawatt of heat. And then there's a lot of other data. So this is just one calculation point. But the smart thing is that typically in a tendering process, we have to calculate the heat pump in many different considerations or under different conditions. And that's why I am able here to make a table. And in this case, I have 9 calculation points. And every point can be calculated as you see down here. So I can have a different ambient temperature, different humidity, different return temperatures and supply temperature of the heat pump. I can have everything calculated here. So, and of course the software is also able to draw in a logarithmic pressure H enthalpy diagram here. And in the end, I can actually export all that into a report where I have all the data into just a Word report showing all the data to the client. So now it's extremely easy for FENtool and our sales team to help you as a potential client or an existing client to calculate a CO2 heat pump. And we are very happy to bring this tool into full operation just now, and it will be a great help for all of us. Thank you very much and have a nice day. Bye.